So before start the actual project explanation, I request you please subscribe my channel. So you can see on the screen up till now I have uploaded more than 66 video on Raspberry Pi. The Raspberry Pi with IoT, that is all this video. Then also IoT with Arduino, all this video are 26. And recently we started the new series on the PIC microcontroller. Before that I also cover the project on the Python web application. So if you want to learn Python, IoT, Raspberry Pi, Arduino, PIC from the scratch and from freely, then please subscribe my channel, please support me. And the most important part is whatever the code I have explained, whatever the project I have created on this YouTube channel, all these projects are freely available. You no need to pay anything for this project. So just if only point is you should watch complete video and you should follow my process. So if you want to learn something from the scratch and freely, then support me and please subscribe my channel and please click on like button. Hello friend, in today's session we will learn how we can design and develop a smart trolley system by using Raspberry Pi and RFID module. So before start this video, I would like to tell you, in the last video I have designed the same project by using the Arduino. So if you want to design and develop the same project by using Arduino, then please watch my last video. The last video thumbnail you can see on the screen, also link given in the description. Okay, so in this video what we will learn, how we can design, like how we can design all this circuit, how we can connect all this circuit with Raspberry Pi. Also I will explain the each and every line of code and how you can run this code into a Raspberry Pi. So after watching this complete video, definitely you will design and develop this project by yourself. So I request you please watch this complete video. Okay, first I would like to tell you what will be the flow of this project. So you can see on the screen we have the LCD module, then we have the RFID module, then we have the some switches module, then buzzer and Raspberry Pi 3B. So I use Raspberry Pi 3B plus. You can use Raspberry Pi 4 also, or any Raspberry Pi, there is no issue. Okay, so what the flow of this project is like that: when any customer enter into the mall or enter into the any shopping mart, then if he want to purchase any item, then he can scan the item RFID tag by using this RFID module. Once he scan the tag, then here on the LCD, then on LCD it will show the item name and the price of item, and at the end it will show the billing, total billing, that total billing of the item that customer has purchased. Okay, then after that let's say if customer purchased 3 items and he wants to remove some item, then customer will press this switch. So once he press the first switch, then it will show on the screen start removing the item. So it means you can remove the item from the bucket, and to remove the item again the customer has to scan the RFID tag, and once he scan the tag, then automatically the particular amount for that item will get reduced from his final billing amount, and here it will show the final billing amount also. Then if the customer wants to add some new item, again he can press the second switch and then customer easily add the new item. And at the end here buzzer also used. Let's say if any customer scan the card, then buzzer also ring, it shows the item get scanned and placed into the trolley. Okay, then third switch is like that to reset the complete system. So if the customer has purchased the item and go out from the mall or any mart, then the admin can press this switch and he can reset the data of this smart trolley, so next customer can easily use that smart trolley. So this is the complete idea and the flow of this project. Now we will see the practical demonstration of this project, then we will see the hardware connection, and then we will see the program part of this project. Okay, now we will see the practical demonstration of this project. Now again I rerun the project. So once I rerun the project, you can see project name on the LCD, and then it will show the start purchasing your item. So again I rerun the project. So you can see smart trolley system start purchasing your item. Now let's say customer scan the first item. So you can see starter salt added 100 rupees, total billing 100 rupees. Then again second item, Bormita added 50 rupees, total billing 150 because 2 item has purchased. Now third item, milk powder added 20 rupees, total billing 170 rupees. Again he want to add the milk powder, he can again scan the same item. You can see milk powder added, then 190 rupees. Now let's say if he want to remove some item, then he can press the first switch. So let's say After press the first switch, start removing your item. So again I will remove this item. So this is the milk powder. So milk powder remove. Now total billing is 170 because 20 rupees is removed from the total billing. Now again I remove this one milk powder. So you can see 150 rupees. So 2 times I remove the milk powder. Okay. Now if I want to add again the milk powder or any other item, so I will press the second switch. So start adding the item. Let's say again I will add the milk powder. So milk powder added 20 rupees. Total billing is 170. Now again I added the second item. Bormita added. Total billing is 220 rupees. So this is the idea behind this project. Now if the customer go out from the mart, then what what admin can do, admin press this switch. Before that, let's say if the invalid item, so this is the invalid key, that means this key is not stored, this card is not stored into our database. So once he scan the invalid card, then you can see here invalid card and nothing gets changes in the total billing. You can see total billing still 220 rupees. So invalid card also detected while adding the item. So let's say if I want to add new item, again I will scan Tata Salt, then total billing is 320 rupees because 100 rupees added. Now if we want to reset this system, then just press the third switch. So you can see trolley reset, start adding your item. Now it will again scan from the start. So once I add again new item, you can see, then Tata Salt 100 rupees. Now total billing is 100 rupees because data is completely reset. So this is the complete idea behind this project. I hope you understand the complete idea and practical demonstration of this project. Now we will see the hardware connection of this project, and at the end of video I will tell you how to add the new item. Let's say this is the fourth key. I already added the 3 card. So I already added the 3 card. So if you want to add the new extra card into your system, how you can add that I will explain at the end of this video, so that you can easily add as many as card in your system if you want to upgrade this project. So I request you please watch this complete video so that you will get complete idea behind this project. Okay, now we will see the hardware connection. So you can see I am using this Raspberry Pi 3B plus. So on Raspberry Pi you can easily see there are those are the pins. So odd number pins comes at this side, even number pin comes at this side. So 1 2 3 4 5 6 like this pins are arranged. So easily you can also like design this pin connection paper and put on Raspberry Pi inside Raspberry Pi pins, so that you can easily identify the pin number. Okay, so this is the first step you have to do. Then second, you can see there is a HDMI cable I am using. This HDMI cable connected. So this HDMI cable is connected to my monitor. So easily you can place this Raspberry Pi like this. Okay, so this is the first step you have to do. Later you can give the power supply from this pin. You can use easily you can use any power supply like mobile charger, 5 volt 2 ampere charger. Okay, so this is the first step that we have to do. Now second step is first we connect the LCD module. So here you can see I am using I2C LCD module. So each I2C LCD module at the back end you can see there are 4 pins, ground, VCC, SCL and SDL. Ground, VCC, SDA and SCL. So this pin, those pin you have to connect. So how to connect those pin I will tell you. So first very important point is you should first connect the ground pin. So ground pin is this one. This is my ground pin from the LCD module. So this should be connected to Raspberry Pi 6 number pin. Okay, so 6 number pin is Raspberry Pi ground pin. So this should be connected to Raspberry Pi 6 number pin. Then VCC pin of this LCD module should be connected to 4 number pin of Raspberry Pi. So VCC pin from this LCD module should be connected to 4 number pin of Raspberry Pi, that is the 5 volt supply of Raspberry Pi. Okay, so this connection I have given in the program. So while explaining in the program I will tell you where you will find this connection. Okay, then after that SDA pin. So SDA pin from this LCD module. So this is the SDA pin, that is the orange color. So SDA pin should be connected to 3 number pin of Raspberry Pi. Okay, and then SCL pin. So SCL pin should be connected to 5 number pin of Raspberry Pi. Okay, that's it, the connection. Very simple connection of LCM module with the Raspberry Pi. We just connected the 4 pin VCC to the 4 number, ground to the 6 number, then SDA pin to pin number 3 of Raspberry Pi, and SCL pin to pin number 5 of Raspberry Pi. Now the next hardware is RFID module. So you can see on the RFID module, here you can see there are pin numbers, MISO, MOSO, then ground, then 3.3 voltage, then RST pin. So you have to just connect the same pin with the Raspberry Pi pins. So which are Raspberry Pi pins, that I will tell you. So first connect the 3.3 voltage pin. So 3.3 voltage pin from this module should be connected to 1 number pin of Raspberry Pi. 1 number pin of Raspberry Pi acts as a 3.3 voltage. So 3.3 voltage pin from this module should be connected to 1 number pin of Raspberry Pi. Then after that the RST pin. So RST pin from this module should be connected to Raspberry Pi 22 number pin. So Raspberry Pi 22 number pin is here. Okay, so I will connect like this. Then after that next pin is ground pin. So ground pin from this module should be connected to Raspberry Pi 39 number. So 39 number is here, so I will connect here. Okay, then after that MISO pin. So MISO pin from this module should be connected to 21 number pin of Raspberry Pi. So 21 number pin of Raspberry Pi is here. 21 is here, and this is the MISO pin. Okay, then after that you can see there is a this one, that is the MOSO pin. So MOSO pin should be connected to 19 number pin of Raspberry Pi. So 19 number pin is here. Then after that you can see there is a SCK pin. So SCK pin should be connected to Raspberry Pi 23 number. So Raspberry Pi 23 number is here. Okay, then after that SDA pin. So SDA pin should be connected to Raspberry Pi 24 number. So that is the 24 number is here. Very simple and easy connection. Okay, next we connect one circuit. You can see this circuit. So how I design this circuit I will explain here on this paper. So basically when you have this switch, each switch having 4 pins. You can see there are 4 pins on each switch. You can see clearly 4 pins on each switch. Then we use the resistor. You can use 1 kilo ohm, 1 kilo ohm resistor or 500 ohm resistor also, no issue. And then we require some buck strip for soldering to connect the wire like this. So I will show you the circuit what exactly. So basically you can see each switch having 4 pins low like this, 1, 2, 3 and 4. Let's consider this is the first switch. Now this pin switch, this is the here 1, 2, 3 and 4. So 4 pin we have. So from the 4th number pin we have taken one resistor. You can see this is the resistor we have taken, and then the resistor next point we have connected to the ground. So this is the common ground. So this is the one part. Now pin this first number pin, consider the first number, not second, not third. Exactly this cross connection, first number pin, it is connected to 5 volt. Here you can see this is the 5 volt. Okay, so this is the one pin connection, one switch connection. Now with the same repeat we have another switch connected here like this. Then again 1, 2, 3, 4 number of this switch. Then from the 4th again we have taken resistor, 1 kilo ohm resistor or 500 ohm resistor. Now this pin is connected directly to the common, you can see common here, common ground. Ultimately it is connected to ground. Then this pin we have to connect it to the VCC. So ultimately we have shorted this like this. Indirectly it is connected to the VCC. Okay, again we have the third switch here. Then third switch I again having the 4 pin, 1 2 3 4. Same way, the from the fourth pin we have taken one resistor and shorted here. Okay, and then from the one pin we have connected like this, common VCC. So all these three pins are connected to common VCC. All these resistor 3 pins are connected to common ground. Okay, now in between fourth number pin and the resistor point, in between fourth number pin resistor point, in between fourth number pin and resistor point of each switch, there is one point out here. You can see in between this one point, then there is second point, and then the third point. So this point is nothing but the Arduino 2 number, 3 Arduino 4 number, 5 number, and 6 number. So from this point we have taken one connection which is connected to Arduino 4 number, Arduino 5 number, and Arduino 6 number. So I hope you understand this circuit. You can see this circuit like this, and very easy circuit you can easily develop on breadboard. If you want to develop on breadboard, please watch my previous video. In that video I have developed this circuit on the breadboard. Okay, now this is the final output of this switch, of this circuit. You can see same connection, each pin having common VCC. You can see this is the common VCC point, then this is the common ground point, and in between switch pin and the resistor, one pin out, one pin out, one pin out, which is connected to the Arduino. That's simple. Okay, once you have this circuit, switch circuit, then easily you can connect. So one by one we can connect that switch circuit. So first pin is ground pin. So ground pin of this switch circuit should be connected to 9 number pin of Raspberry Pi. So this is the ground pin of this switch circuit, should be connected to 9 number pin of Raspberry Pi. Okay, then VCC pin of this switch circuit, that should be connected to 4 number. VCC pin should be connected to 2 number pin of Raspberry Pi. So button circuit and switch circuit is very easy. Then after that, first switch should be connected. So first switch pin should be connected to 11 number pin of Raspberry Pi. So first switch is 11 number. Then second switch should be 13 number, and last switch should be 15 number. Okay, so very easy circuit we have designed and connected. Now the last is very easy circuit, that is the buzzer having only 2 pins, one is VCC and one ground. So ground pin from that buzzer, so ground pin, that is the black pin of that buzzer, should be connected to 25 number pin of Raspberry Pi. So here is the 25 number pin of Raspberry Pi. Okay, very easy circuit. And then positive pin of buzzer, that is this red pin, should be connected to 7 number pin of Raspberry Pi. Okay, so 7 number pin is connected. Okay, so at the end we have completed the hardware connection. Now before give the power supply, just verify VCC ground connection once again. So 3.3 voltage from this RFID module should be connected to 1 number pin. Yeah, it is correct. And ground pin from this RFID module should be connected to 39 number. Yeah, that is correct. Then ground pin from the buzzer should be connected to 25 number. Yeah, it is correct. Then ground pin from this switch module, so this is the ground pin from this switch module, that should be connected to 9 number. Yeah, correct. Then VCC pin from this switch module connected to 2 number. Yeah, correct. Then LCD ground pin should be connected to 6 number pin, LCD ground 6 number, correct. And VCC pin to the 4 number. Yeah, correct. So VCC and ground pin connection are very correct. So now we can give the power supply and we will check the hardware connection. So now I will give the power supply in front of you, and then we will see whether our hardware is working or not. Okay, I have joined all hardware in front of you. Now I am giving the power to Raspberry Pi to check whether my connection is okay or not. So power is given. Now I can see my Raspberry Pi start booting. So once I click on run button, now you can see LCD also working. It's showing smart trolley system. Start purchasing your item. That message is showing on the LCD. Now I will place any item to just verify whether it's working. Yeah, it's working. Bormita added. Now I remove the bormita by clicking on the first button. Start removing the item. Remove bormita. It's also working. Now again I start adding the item. Also added, and now I press the third switch to reset the trolley. Okay, it's working completely perfect. So if you follow the video and if you follow my hardware connection explanation, definitely you can also design and develop this project by yourself. Now we will see the programming part of this project. Okay, now we will see the programming part of this project. So very important point is you should download this folder from my web page link. The web page link given in the description. So once you download, you will get zip file. You have to unzip that one. So after that you will get this 2 file. So very important part is first you should go into Raspberry Pi, then preferences and configuration. So here you have to first enable the SPI communication, I2C communication, because SPI is required for our RFID module and I2C is required for our LCD module. So for that two hardware you have to enable this communication. Okay, so once you enable, then you have to download some library. So which library you have to download? Just open this command file. So once you open the command file, go to the black window and here you will find Raspberry Pi. Then you can copy one by one command from here, like copy this first command and paste and press enter. Likewise you can install all this command one by one. I already installed all this command in my laptop, in my Raspberry Pi. You have to install those commands so that your I2C module, I2C LCD will work and RFID will work in your Raspberry Pi. So these are some basic settings you have to do in your Raspberry Pi before start the program. Okay, so once you install all this library, next point is you have to open the program. You can open program in many different way. First you can right click here, open with Python 3, or just double click here. So once you double click, program will be open in Thony browser. You can see that is Thony browser. Also after you right click, open with Thony browser, also option there, you can open with Thony browser. So these are the two ways you can open the program. So at the starting of every program you can see there are some connection I have explained, like RFID connection, which are the pin of RFID module, which are the pin of Raspberry Pi module, where to connect. So all these are information are given here, like VCC pin from the I2C module should be connected to 4 number, then switch connection, add switch, remove switch, where to connect, then again buzzer, here is a buzzer connection. So here is the buzzer connection. You can see buzzer pin, Raspberry Pi pin. So if you want to check the connection, you can check with this program also. Now first you can see on the line, when program started, we imported the I2C library, then time library, some GPIO library, and then our RFID library. Then we consider as a Raspberry Pi as a board because we can access Raspberry Pi as board or BCM chip, but for our project we are accessing the Raspberry Pi as a board. Then some warning we set to the false, because whenever we run the program, Raspberry Pi gives us warning that whatever the GPIO pin you have used is already used before. So to avoid that warning, we should use 49 number line. Okay, 50 number line. Then buzzer we connected to 7 number, then remove switch, add switch, reset switch, whatever the connection that they mention here, like 7, 11, 13 and 15. Okay, so connection, whatever the connection we use for our hardware, that mention here. Then after that, buzzer pin as output pin and all the switch pin work as a input pin. That's why all the input output are defined from line number 55 to line number 58. Then at the starting we have to turn off the buzzer, that's why we are sending the low signal, that is the false signal on the buzzer by using this line. Then after that we are defining some object for our RFID module so that we can access the RFID model. Then after that you can see there are LCD definition. Here address is 27. In your case, if you want to find the address, then you should run this command I2C detect y1. So once you run the command, you will find the address. Like here you can see, if I run this command, then my address is 27. So in your case your address may be different or same. Just check if your address is same or different. Okay, then after that some flag are there, variables are there, we will use that variable later. Then you can see card number 1. So whatever the RFID card number, how to read that card I will tell you later, but first focus here. Like your card number 1 is this, card number 2 is number this, card number 3 is number this. So your card number should be mentioned here. Then in the database you can see item name and the item price you have to define here. So likewise you have to define item name and item price. Then after that at the start it will show smart trolley system, smart trolley billing system on the LCD. Then again LCD clear and it start showing start purchasing your item by using this these lines. Then after that you can see in the while one loop, first we are taking the input from remove switch, add switch and reset switch. If the like switch 1 is for the remove switch, so once the remove switch is pressed, then you can see remove flag set to the 1, add flag set to the 0. On the LCD it will show start removing your item. If the switch 2, that is the add switch, if pressed, then from this line the switch is detected whether it's 0 or 1. So once it's 1, like switch status is 1, you can see GPI high means 1. Then add flag set to the 1 and remove flag set to the 0, and on LCD it will print start adding your item. Then after that you can see GPIO status, GPIO input reset is there. So once you press the reset switch, then it will go here, it will check whether reset switch is pressed or not. Once it pressed, you can see add flag set to the 1, remove flag set to the 0 and billing price set to the 0, and on the LCD it will print trolley reset start adding your item. So this is the logic behind the 3 switches. So at the starting you can see here I have set the add flag to 1. So initially when you start the system, that means no need to press any switch because already add flag set to the 1. So here you can see once we scan the RFID from this line number 122, we are scanning the RFID. If there is tag, then it will print the tag number. Then after that, if there is a no RFID tag scan, it will break, and it will break means it will again come to the while one loop. So that is the logic here. So once you scan the tag, then print the tag number on the Raspberry Pi, and here it is checking whether add tag flag is 1 or not. So once add tag flag is 1, that means you are adding the data, adding the item into your trolley. So on the LCD it will print LCD write, it will print database ID nothing but the tag number of 0. So here you can see in the database we have the 3 IDs. 3 ID, tag number 0 means this name, tag number 1 means price, tag number 3 means tag number. Okay, so here you can see after you start adding the item, like signing the item, then it will print the ID name on the LCD by using this line. Then on the second line it will print ID price, because you can see database ID 1, database ID 1 means price, database, this is the database ID 1. So it will start 0 1 2, so ID 1 means price. So on the LCD it will print your item name and price. Then it will add the billing price initially 0 plus database ID 1 means bill, price of that item. So total billing will be added like billing price plus price of item. Okay, so once billing gets added, then here you can see here it will print buzzer true, buzzer false, that means buzzer gets ring on. On the LCD it will print total billing, and then on the LCD it will print billing price plus rupees, means billing price plus RS will be print on the LCD. So it is the one part. Now once you press the remove button, so once you press the remove button, then add flag set to the 0. So it will not come inside this loop, it will come inside here, because remove flag set to the 1 and billing price should be greater than 0. Then on the LCD it will print remove. Once you scan the item, then it will print remove, then item name, and then billing price is nothing but billing price minus item price. So at the end again it will print total billing and billing price. So this is the logic behind the code. Then let's say if there is no valid tag, so if there is no valid tag, then it will go into this loop, exception loop, and it will print invalid tag, scan item again, then it will show total billing and billing price and rupees on the LCD. And once you press the reset button, then I already told you billing price set to the 0. So this is the idea behind this code. I hope you understand the idea behind this code and logic. Now how to run this code. So once you click on this run button, you can see, once you click on this run button, if there is all library get installed, it will print none. None means there is no scan on the RFID tag. So once I scan something on RFID model, you can see RFID number gets printed here. Buzzer not ring, that means it is an invalid tag, so that is means it is a new tag. And if buzzer ring, again I scan, so you can see buzzer ring, that means the valid tag. So in this way you can copy the number. Let's say I stop the program. Okay, now what happened when I scan the first tag, buzzer not ring, because it is invalid tag. Now I copy this number because it is of invalid tag, so I copy this number. Once you scan the tag, you will find this number. Then you can go here, enter, once you press enter, you can copy this last line, okay, you can copy, you can paste here, you can add 4, card number 4, then you can give any name for that item, let's say pen, pen price I set as, let's say 10. Always remember you have to give the name and the price into quote. Okay, then here you can give card number 4, then here you can add card number 4 again. Okay, then after that you can add card number 4 here. Just copy this name, four equal to, then after that you can copy that number of card from here and paste here. And save the program. You can click on Ctrl S, it will save the program. So once you save the program, just click on run button, just validate your program should work. Now it is working. Now I will quickly scan my all card, so it should show all name on LCD. Pen I can see 10 rupees on the LCD. Then Bormita also I can see 50 rupees. Then Tata Salt also I can see 100 rupees. And milk powder also I can see 20 rupees, and 180 is my total count. So in this way you can add as many as card into your program. I hope you understand the complete code and logic and complete hardware of this project. If you like my content, please click on like button, please subscribe my channel, please support me. Thanks for watching this video.